Computers are everywhere. They are in our homes, offices, and pockets. Computers are powerful tools that have revolutionized the way we live, work, and interact with the world. But what exactly is a computer? At its core, a computer is a machine that processes information. It takes in data, performs operations on that data, and produces output. The significance of computers lies in their ability to process vast amounts of information quickly and accurately. This has led to countless breakthroughs in science, medicine, engineering, and countless other fields. Computers have become indispensable to modern life, and their influence will only continue to grow in the years to come. To understand how computers work, we need to understand how they think. Computers use a language called binary code, which consists of only two digits, 0 and 1. Each digit in binary code represents a bit, which is the smallest unit of information a computer can process. By combining bits into groups, computers can represent numbers, letters, symbols, and instructions. For example, the letter A is represented by the binary code 01000001. Every piece of data stored or processed by a computer is ultimately represented in this binary form. Understanding binary code is essential to grasping the fundamental principles of computing. At their most basic level, computers perform calculations using simple arithmetic operations, like addition and subtraction. These operations are carried out by electronic circuits called logic gates. Logic gates take in binary inputs, zeros and ones, and produce a single binary output based on their function. For instance, an AND gate outputs a 1 only if both its inputs are 1. By combining multiple logic gates, computers can perform more complex calculations. These calculations form the basis for all computer operations, from simple tasks like opening a file to complex simulations of the universe. The speed and precision with which computers perform these calculations is what makes them so powerful. The history of computing can be traced back centuries to early mechanical devices designed to aid in calculations. These devices, though primitive by today's standards, were revolutionary in their time. They laid the foundation for the complex machines we rely on today. One of the earliest examples is the abacus, a simple counting tool used in ancient civilizations. The abacus was not just a tool for merchants and traders, it was an essential instrument for scholars and mathematicians. Its design varied across cultures, but its purpose remained the same: to simplify arithmetic operations. In the 17th century, mathematicians like Blaise Pascal and Gottfried Wilhelm Leibniz developed mechanical calculators capable of performing more complex arithmetic operations. Pascal's calculator, also known as the Pascaline, could add and subtract, while Leibniz's machine could perform multiplication and division. These inventions marked significant advancements in the field of computation. These early machines paved the way for the development of more sophisticated computing devices. Over time, mechanical calculators became more refined and capable, incorporating new features and improving accuracy. Each iteration brought humanity closer to the digital age. Perhaps the most significant development in early computing was Charles Babbage's analytical engine in the 19th century. Babbage's vision was far ahead of his time. His analytical engine was designed to be programmable, using punch cards to input instructions. This concept of programmability is a cornerstone of modern computing. Though never completed, Babbage's design envisioned a machine capable of performing any calculation, making it a precursor to the modern computer. His work inspired future generations of inventors and engineers, who would eventually bring his ideas to fruition. These early pioneers laid the groundwork for the digital revolution that would follow. Their contributions, though often overlooked, were crucial in shaping the technology-driven world we live in today. From the abacus to the analytical engine, each step in the evolution of computing devices has brought us closer to the advanced systems we now take for granted. Section 5. The Dawn of Electronics, Vacuum Tubes, and the ENIAC. The 20th century witnessed a dramatic acceleration in computing technology with the advent of electronics. The invention of the vacuum tube, an electronic component that could control the flow of electricity, revolutionized computer design. During World War II, the need for faster and more efficient calculations spurred the development of the first electronic computers, such as the Colossus in Britain and the ENIAC in the United States. These massive machines used thousands of vacuum tubes and consumed enormous amounts of power. However, they were significantly faster than any previous computing device and demonstrated the potential of electronic computing. Section 6. The Transistor Revolution: smaller, faster, more efficient. The invention of the transistor in 1947 marked a turning point in the history of computing. Before transistors, computers relied on bulky and unreliable vacuum tubes, which were prone to frequent failures and consumed a lot of power. The transistor, a tiny semiconductor device, changed all that. Transistors performed the same function as vacuum tubes but were smaller, faster, more reliable, and consumed less power. This meant that computers could be made much smaller and more efficient. The reliability of transistors also meant that computers could run for longer periods without maintenance. The adoption of transistors led to a dramatic miniaturization of computers. Early computers that once filled entire rooms could now fit into a single cabinet. This miniaturization opened up new possibilities for computing applications and made computers more accessible to a wider range of industries. Mainframe computers, still large and expensive, became more powerful and accessible to businesses and universities. These institutions could now afford to invest in computing technology, leading to advancements in research, data processing, and business operations. The transistor revolution paved the way for the development of integrated circuits, which combined multiple transistors on a single chip, further shrinking computers and increasing their capabilities. Integrated circuits were a game changer, allowing for the creation of more complex and powerful computing systems. This period saw an explosion of innovation in computer design and set the stage for the personal computer revolution. The advancements in transistor and integrated circuit technology laid the foundation for the development of personal computers, which would eventually become an integral part of everyday life. Section 7. The Microprocessor, a computer on a chip. In 1971, Intel introduced the world to the first microprocessor, the 4004. This tiny chip contained all the central processing unit of a computer on a single piece of silicon. The microprocessor revolutionized computing by enabling the creation of smaller, more affordable computers. It led to the development of personal computers, which brought computing power to the masses. The first personal computers, such as the Altair 8800 and the Apple II, were primitive compared to today's machines, but they sparked a technological revolution. Section 8. The Digital Age: Personal Computers and the Internet. The 1980s and 1990s witnessed the rapid proliferation of personal computers. Companies like IBM, Apple, and Microsoft led the way, making computers more user-friendly and accessible to the general public. The development of graphical user interfaces, the computer mouse, and software applications made computers easier to use and opened up a world of possibilities for users. The rise of the internet in the 1990s connected computers globally, creating unprecedented opportunities for communication, collaboration, and information sharing. The digital age had truly begun. Section 9. The Future of Computing: Artificial Intelligence and Beyond. Today, computers continue to evolve at an astonishing pace. The advancements we are witnessing are not just incremental but revolutionary, transforming every aspect of our lives. From the way we communicate to how we work and entertain ourselves, the impact of computing technology is profound and far-reaching. Moore's Law, which states that the number of transistors on a chip doubles approximately every 2 years, has held true for decades, leading to exponential increases in computing power. This relentless progress has enabled the creation of smaller, faster, and more efficient devices, making technology more accessible and integrated into our daily lives. Artificial intelligence, machine learning, and deep learning are at the forefront of this technological revolution. These technologies are enabling machines to perform tasks that were once thought to be the exclusive domain of human intelligence. From recognizing speech and images to making complex decisions, AI is transforming industries and creating new opportunities. Quantum computing, another groundbreaking area of research, promises to solve problems that are currently beyond the reach of classical computers. This includes everything from cryptography to drug discovery, and even climate modeling. The potential applications of quantum computing are vast and could revolutionize fields such as medicine, finance, and logistics. The future of computing promises to be even more transformative than the past. As we continue to push the boundaries of what is possible, we can expect to see innovations that will reshape our world in profound ways. From smart cities to personalized healthcare, the possibilities are endless. As we continue to unlock the potential of computers, we can expect to see innovations that will reshape our world in profound ways. The journey of computing is far from over, and the next chapter promises to be even more exciting and transformative.